Hi everyone. Let me know if the sound's working. Hi guys. We have a couple questions from previous lives that people have asked me to go through first, but I'm just waiting to see if those people are here yet. Got the Hexagon question here as well from last year. So just let me know if you're here if you want to go through the Hexagon question. If not, then we can obviously, we'll just wait. What else would anyone else like to go through in the rest of today's live? Just let me know. Oh yeah. Okay, the person who wanted to go through the Hexagon question, I think they're going to be here at like 20 past. That's so we'll come back to this one. We can go through quadratic inequalities. Yeah, because the first bit's just the same as like a quadratic equation, isn't it? You just solve it in the same way. Normally, you're gonna factorize it most of the time, but yeah, it's at the end. Then you have to figure out how the signs go. Let me grab a question. Also, just for those of you who don't know, in the paper, normally we do a past paper at 7 o'clock today. It's actually going to be the predicted paper. Yeah, it's the predicted paper. I've written it myself. Like I've literally just like written it from scratch. So I have linked it in the description of that live. Because you know how you can see the lives ahead of time on my channel. It's linked in the description. It's like a Google Drive link. Hopefully it works. I think I tried to change the access so that you could open it, and it's in there. So you can if you go to that live, look in the description, and then I've linked like the PDF for the paper, and then also a PDF of like a scan of my answers as well, so you can have a look at that beforehand if you want to. But it's just my paper, like I've literally written it myself, so that's why it's on like a Google Drive. Hang on, let me grab a quadratic inequalities question as well. So yeah, for anyone who wants to go through a predicted paper, paper 1, obviously, non-calculator, that will be at 7 o'clock today, because everyone voted to have it this week. I will also, I've actually filmed going through it myself, so I will do an edited version that will upload on Monday anyway, so that one will obviously be a bit, a bit quicker. So that's Monday. Okay, so we've got here, this is just a kind of the most basic version I could find, just so you could show you the ending. Obviously, solving it, we're just going to pretend that it's just like a normal quadratic equation, so you can almost write the equal symbol if you want. Obviously, normally, most of the time, you're going to try and factorize. If this was on paper 3 from the past paper, you can obviously solve it by using quadratic formula if you prefer. You don't have to factorize it, but I feel like normally we would kind of try to factorize, wouldn't we? So this one we'd have a 2x and an x. Obviously we're multiplying to make -2, so 2 and 1, but which way round would it go to make +3? I would say probably +2 here to make +4x, and then -1 to make -x. Then obviously solve it just as normal, so you'd get positive 1/2 or -2. So that bit, I think, yeah, that bit will give you 2 out of 3 marks anyway. It's then the last mark is the inequality bit. So there's 2 ways to do it. You either just memorize, depending on which way the symbol faces. You can memorize. If it faces the quadratic, it means this answer. If it faces the 0, it means the other answer. Because for quadratic inequalities, there are only 2 possible formats of answers, right? There's only 2 possible formats. So you can memorize it or you can figure it out. I'll show you, obviously, if you memorize it. If it faces the quadratic, is there enough space? If it faces the quadratic, then it's going to be 2 sets of inequalities. So x would be smaller or less than, x is less than the smallest value, whichever is your smallest value, in this case it'd be -2, for example. And then the other one would be x is greater than the biggest value, which would be, in this case, the half. So that's one format. The other format is obviously if it faces the other way. If it faces the 0, then it's going to be a range. So x will, that's a bit easier because you just put x between, you know, obviously the small and the big. So it's either of those 2 answers. Yeah, I've got your question. I was just waiting for you to come to the live. We can go through that after this one. Yeah, so that's your 2 possible answers. So you can either memorize it. If it faces the quadratic, 2 separate answers, but remember x is less than the smallest one and greater than the biggest number. Or if it's less than 0, it's between. So in this case, you can see it's facing the quadratic. So my answer would be x is less than the smallest one, so -2, and x is greater than the biggest number, which is 1/2. That would be what I would do. Now, the way that you could figure it out if you feel like you're not going to be, like sometimes I'm not really sure if I'm going to memorize it properly. It's just something to memorize, basically. You just memorize it, the answer. Now, I'll show you why that works, or I'll show you why. Now, you can either choose to memorize it. I feel like sometimes I memorize things and I'm like, was I right or did I mix it up? Because obviously if you mix it up, then you're wrong. So I just figure it out. What you can do if you want is once you've obviously you have to solve it first. I just draw a little sketch of, because obviously I know a quadratic and this is a positive one, is like a U shape, isn't it? So I just draw a really rough little sketch. It doesn't have to be accurate at all. They're not going to mark you for this. So like -2 would go there, 1/2 would go here, you know, roughly. And then it's like a U shape. So, okay, something like that, right? Doesn't have to be accurate, as I said. Now, this is what we're talking about with the 0. Normally, like this graph here would be 2x squared plus 3x minus 2 equals y, right? Do you see how then I can compare it? Obviously, I'm like over-explaining this, right? This bit here is the y bit, and then obviously the other side is the quadratic, isn't it? So what I'm trying to say there is when it says is greater than or less than 0, they mean when y is 0. So that is the x-axis, isn't it? That is the x-axis, right? So just think of it as, in terms of y, that's a vertical thing. So I'm saying, if I read this, I'd be saying, am I looking at the section of my quadratic that is above the y equals 0 line, the x-axis, or am I looking at the section of my line that is below? That would be below, wouldn't it? Less than, and that would be above, greater than. Because you see how now that tells me whether I end up with, so above, you see that's why I get 2 separate inequalities, because there's kind of 2 tails. And then below, let me get a different colour, below, do you see why that's a range? Because it's between, if you think about, we're talking about the x values, aren't we, in terms of our answer. Do you see how the range is, the x is between -2.5, for example, or if I'm looking at above greater than 0, then I'm looking at the 2 tails, which, do you see how that would make the x on the left-hand side less than -2, or bigger than 1/2, because technically the quadratic goes on for infinity, doesn't it, vertically? Like this would go up and up and up. There's no kind of limit. So you can use that logic if you prefer, or you can just memorize it and say, right, if the symbol faces the quadratic, like it does in this example, it means two separate inequalities. And I have to write that x is less than the smallest, whatever, you know, when you get your two solutions, whatever the smallest number is, you put x is less than that. And then you put, then for the other one, x is greater than the biggest answer. So in this case, you see I put smaller than minus 2 because that was the smallest value on the number line. And then x is greater than a half because a half is obviously the biggest number. Or if your symbol is facing the 0, then you just put it as a range. So you either memorize it like this, just memorize those two possible solutions. There's only those two possible formats, if that makes sense. So at least you know. And if you're not sure, you could always just guess, to be fair, because you know it's only going to be one of these two answers. If you're not sure, don't leave it blank, just guess. But yeah, otherwise you either memorize it. If it faces the quadratic, two separate answers. If it faces the 0, one range. Or you can use the logic of the graph, just draw a little quick, sketch of the graph once you've got your two values and go, am I looking at below, less than 0, so below the y equals 0 line, so that's the range, that curved bit there, isn't it? Or am I talking about, and am I looking at the bit that's above the x axis, the y equals 0 line, which is, do you see how that splits into two kind of tail things, two separate ones, doesn't it? So you either memorize it or you kind of use this graph logic to figure it out on the day. That's up to you. It depends if you prefer memorizing, depends if you prefer kind of just drawing a little sketch and visualizing it. I don't know if does that answer your question? So this is the bit that you could memorize if you want. Obviously you just apply your numbers depending on what numbers you get. Yeah, you want to repeat it again? Which is the bit that you're not sure about in this like this bit over here? The when I say smallest or biggest, or which is the bit that doesn't make sense? So obviously a quadratic, you'll always get two answers, won't you? So one will be smaller and one will be bigger. If you think about a number line, and that's what I mean by the smallest number and the biggest number, if that's small and big. Yeah, just let me know which is the bit that you weren't sure. Oh, all of it. Okay. Okay, if I start again, what I was saying about this is the memorize, you don't have to memorize it. You can use the graph if that makes sense to you. Memorize. There's two possible answers, two possible, when you do a quadratic inequality, obviously this is the first bit, isn't it? That gives you 2 marks. That's fine, isn't it? That's just solving a quadratic normally. You get your two values. Then at the end, we have to put it back into an inequality, don't we? So that's the bit that we're talking about here. So with quadratic inequalities, there's only 2 possible formats for your answer, right? There's only 2 possible ways to write the answer. Either you're going to get 2 separate inequalities, or you're going to get a range. So one inequality, but the numbers create a range. That's the 2 possible formats. Now, the way that you decide which of these 2 possible formats is the answer is based on which way the symbol faces in the question. So do you see how I've written here? If your symbol faces, do you see how it's facing towards the quadratic? So if you're saying your quadratic is greater than 0, that's what that first one means, isn't it? It could also have an equal, it could be like that, yeah. In which case you would, if it was like that, you would just copy. You'd copy the same. If it has the equal to part to it as well, just copy the equal to. If it doesn't, don't put the equal to. I think from my experience, most of the time there's not an equal to, but do you know what I mean? If it does have that, you just copy it. The more important thing is which way the symbol faces. The equals part of that doesn't really make any difference to how it's facing, does it? So if it's facing towards the quadratic, or if you're saying that the quadratic is greater than 0, your answers have to be in two separate inequalities. One, x you put is less than, and then you choose whichever is your smallest value. Whatever solutions you've got, you put the smallest value. X is always smaller or less than the smallest value that you got. And then separately, you write x is bigger or greater than the biggest value. So whatever numbers you've got, you obviously apply that. Right, and then if it's the other way around, if you've got a quadratic inequality and the symbol is facing the 0, or it's, you know, in that case you would read it as the quadratic is less than 0, then it would be, your answer would be in the format of a range. So let's say this one was the same. You would, in this case, I would put -2 is less than x, which is less than a half. Like, that would be the answer if it was facing the other way. Can we swap the answer location? Do you mean this one up here, the smallest and the biggest? Because you can't swap that. It has to be less than the smallest one, bigger, like greater than the biggest one. I mean, you could write it the other way around if you, like, in terms of this, if you wanted, but you can't change, like, the symbols. Yeah, you can write it like that, but do you see how I've kept the symbol the same? X is still greater than the biggest one, and x is still smaller than the smallest one. You could, like, you can't do this. That would be wrong, right? You can't write the symbols the other way around. That would be incorrect. Because then that would just be a range, wouldn't it? But you could, yeah, it doesn't matter which way round you write your inequalities and the answer, if that makes, as long as the symbols are facing the right way, it doesn't matter which one you put first and which one you put second. Yeah. Yeah. Okay, we're going to do one more question, and then we're going to do the density question, okay? The one that has been sent in before. Okay, let me find... Obviously, there's a lot of ones where they've also put a context to it. That was kind of more of a straightforward one. Sometimes you might need to rearrange it as well. That's also fine. Let me try and choose one. Just going to grab it. I know this is quite a big question, but we can just do maybe one of them. Because the symbol faces the same way for both, so it would be the same answer. Oh, no, that's just the... Oh, that's just the marks. Get the actual question. Yeah. There's one with multiple inequalities, or do you want one that's got, like... You know, it's got a context, like a... Actually, there's going to be one in the predicted paper as well, by the way, so you'll be able... That's like the last question on the paper. You'll be able to do that as well. So you can practice that when we go through the predicted paper. So this one, they're obviously both quadratics. I'm just going to look at this one, right? We're going to... I think this was a calculated one. Because this had... Was this? Oh, I don't even have it written down if it was calculated or not. Because this was such big numbers, you can either factorize it, or... I think I used the quadratic formula because it was such a big number. Yeah. So... You factorize it, solve it. I mean, we're not practicing that bit, are we? So, for example... I think it factorizes into 5x plus 9. What's this? Minus 9. There's a 9, and then there's a x and an 8. Yeah, I think it's plus 9 and minus 8. Does that make sense? Minus 41. Yeah, okay. So I would, you know, obviously solve that. So you get minus 9 over 5 or 8. That bit's fine, isn't it? And then I just go, well, it's, you know, it's facing the quadratic. Do you see how it's, the symbol is facing the quadratic? That if I memorize it, that tells me I need two separate answers. So x in this case would be less than the smallest number, which is the minus one, obviously the negative one. And x is greater than the biggest number. Like, I would just memorize that basically. So when you've got this, I think it depends. You can still use trial and error, or there is a method called splitting the middle term. I think the reason why I probably maybe wouldn't use splitting the middle term in this case, because the numbers are so big, I think I would just do trial and error, especially because 5 is, if it's got prime numbers in it, then at least it's, yeah, I would probably just use trial and error for that one. You could use splitting the middle term. The problem with that is that you would do 5 times 72, and that would be such a massive number, wouldn't it? Oh, trial and error, just as in just testing out numbers. So you're saying when we factorize them, we know that the two numbers, so the, you know, in this case the 9 and the 8, but the two numbers, if we didn't know what they were, multiply to make negative 72. So I know it's a plus and a minus. But they also add, when I add them together, they make minus 31. So I'm just thinking, right, what are my factors of 72? Obviously 1, 72, like actually it's got loads, isn't it? You know, you don't necessarily have to list them, but in my head I kind of go through them. 2 and 36, I think 3 goes into it. Is it 3 and 24? I don't even know. me try it. Yeah, 3 and 24. 4, 5, 6 and 12, 7, 8, 9. Those are all of my factors, right? And I just have to figure out, obviously, because it's a 5x squared, I know because it's a prime number, so it's a little bit easier. I know it has to split into 5x and x. So then I'm thinking, well, whatever goes here will be multiplied by 5 in order to add up to make 31. So then I'm just subbing in numbers and testing it out. You can use the AC method for sure, it's up to you. The only thing with the AC method is you would have to do, because it's A times C, isn't it? The splitting the middle term is the AC method. You would have to do 5 times 72, which for me personally, that gives you, you might find that easier, you might not. That gives you 360. So you're looking, in that case, you'd be looking for two factors of 300, well, technically, I guess minus 360, that add up to make minus 31. Now, you might find that easier, or you might find that harder because it's a bigger number. You might think, oh, actually 360 is such a big number that I don't really want to think about factors. That's the only reason why I was like hesitating. Okay, so I'm just going to put it on a spare page. I'm sorry, we will get to your density question in a minute, I promise. So let's say it was that. So you know how quadratics are always like A, this is B, this is C. So some people call it splitting the middle term, some people call it the AC method. I'm assuming the AC is the same thing, right? If you're solving it, yeah, you can solve it however you want. That's why I was saying if you wanted to, you could use quadratic formula. You've also suggested completing the square. You could complete the square if you wanted to and solve it that way. Yeah, because they haven't specified how to solve it. You just have to solve it. So you could use any of the three methods. Some version of factorizing, you could do completing the square. You could do quadratic formula. It's up to you. So yeah, AC, you would have to multiply A and C, right? So you do A times C. So include if it's got a negative, right? So that would give me, as we said, minus 360. So I need to find, instead of finding factors of 72, I'm now finding factors of 360, which you might find easier, you might find harder because it's a bigger number, but those two factors still have to add up to make minus 31. Obviously, one of them has to be a positive and one has to be a negative because it multiplies to make a negative. So do you see what I mean? Like in my head, I thought, oh, I can't be bothered because that's such a big number. That was just me. I couldn't really be bothered. But I would probably use this method on, I would probably use the splitting the middle term method. You know, when you've got a number in front of the x squared that's not a prime number. So this is prime. I know it's going to be 5x and x. If it was like 6x squared, where it could be 6x and x, or it could be 3 and 2. Do you know what I mean? That's probably when I would use splitting the middle term, but it's up to you. You can use it at any point that you want to use it or not. You know, that's, I mean, it's all up to you when you want to do trial and error, when you want to use splitting the middle term, if you want to stick with one always, or if you want to mix them up depending on the actual quadratic in front of you. It's up to you. I mean, there's not a kind of set answer. So I don't even know. Well, we know it's 9 and 8 in the end, don't we? Let me just figure out what it would be. Yeah, I think it'd be like, for example, 45 times 8. Does that work? And how does that make? That doesn't add up to minus 31, does it? Hang on. Oh no. 40 and 9. And then which one would be negative? Well, then 40 would be negative because if I'm adding to make minus 31, it'd be that. And then this is the bit where you split the middle term, right? Yeah, you're right, 9 and 40, exactly. When you split the middle term, you rewrite your same quadratic, but you literally you split the middle bit. So instead of writing minus 31x, I'm going to write it like this. Now, it doesn't matter which number goes first or which one goes second. It doesn't matter. It will work either way. So minus 40x plus 9x minus the 72. See how that's exactly the same quadratic? I've just split it. If you were to simplify that, you'd get the same thing, wouldn't you? And then you factorize both halves separately, right? So, and that would obviously be into single brackets. So the first one would be 5x, and then you get x minus 8. And then the second one, what could I pull out? 9, and then x. The brackets have to be identical, right? So I know that needs to be minus 8, which tells me this can be plus. So your brackets, when you get two brackets, they have to be exactly the same, okay? And then all you need to do is obviously one of those is your bracket, the x minus 8 is one of the brackets. And then the other bracket is whatever's on the outside. At least with splitting the middle term, you know if you're right or not, because if you get 2 of the same bracket, you know that you've got it right. Yeah, exactly. That's the splitting middle term. But you still, the thing is with splitting middle term is you still have to some extent, you still have to do a bit of trial and error. Like, you can't kind of get rid of that. Okay, so in terms of the signs, it's more so to do with this bit here. They have to add together, not only to make 31, but to make negative 31. So in that's how I figured out which way round it goes. Because obviously for multiplying, it doesn't matter, does it? Either way, it would multiply to make a negative. But yeah, it's in terms of the adding bit, minus 40 plus 9 would make minus 31. So that's why I put it that way around. It's based on the middle term. So that's splitting the middle term method. You can decide whether you think that's helpful, whether you think that's just more complicated. It's up to you. Like, again, this is all kind of personal preference. It's up to you. Whatever works for you. But yeah. Okay, so I'm just going to go back. We're going to do the density question now, because that was the first one that was asked. Just let me know if you're still here if you want to do the density question, because I don't want to talk through it if you're not here. And then we'll do the hexagon question after that, okay? And then I'll have a look at everyone else, what you've mentioned. Yeah, okay. You emailed me to say that you told me what your answer was. When I worked through it myself, I also got the same answer. So I'm assuming your working was fine, but we can obviously talk through it. So for density, you have to have memorized the formula, right? They won't give you the formula. So I just memorize it as a formula triangle. Density is mass over volume, so mass is at the top. Doesn't really matter which way around you put the density or the volume, to be fair. But just remember, mass is at the top. So normally when I get density questions or any question where you've got the triangle, so for example, speed, distance, time, the pressure, force, area, like all of those, what I tend to do is you can just have a look at, they'll normally give you obviously 2 out of 3. So you just figure out, well, which one haven't they given me? Now, obviously here, so we've got liquid A has a density, so if I put A, they've given me the density of 1.8 grams per centimetre cubed. Liquid B, if I list that here, we've also got the density, 1.2. Then they've said 80 centimetres cubed of liquid A, which is the volume, isn't it? So they've given me the volume, is mixed with 40 centimetres cubed of B. So that's the volume of B. And do you see how then, to make obviously 120 of liquid C, work out the density of liquid C. So for C, move my page a bit. To find C, I would need, I want to know the density, I would need to know the total mass and the total volume, wouldn't I? Now I know the total volume of C is 120, but do you see how I don't have the mass? So what I would do is I would work out the mass of A and the mass of B, because then when you mix it, it would just add, wouldn't it? Right? So obviously then, in terms of finding mass, I might formula triangle, I'm multiplying it, so I would do 1.8 times 80, so I'm assuming this is a calculator question. Gives me 144, so for A that'd be 144 grams, and then I do the same for B, obviously with the numbers for B, 1.2 times 40 gives me 48. And then obviously for C, do you see how that would just be those two added, wouldn't it? Total mass for C, so 48 add 144 is 192. And then now the only thing missing is obviously then density, right? So density would be mass over volume, so we do 192 over the 120. I don't know what paper this is from. Yeah, I don't know if it's calculator or non-calculator. I don't know if... Do you know what paper this was from? If it was a calculator or non-calculator? I feel like it'd be calculator, but... Yeah, it's a calculator, yeah, I feel like it would be. I mean, obviously they could ask a density, mass, volume question on the non-calculator. They would just probably choose numbers that maybe were a little bit easier. I mean, this is not impossible, but a little bit easier probably if it was on a non-calculator. So I got 1.6, which is what you mentioned you also got. So I don't know if you did it the same way, or however you did it, you also got the same answer. So I'd imagine both methods would be the same, would be fine. Okay. So yeah, normally I just kind of list out what have I got, therefore whichever one is missing, I'll just work that one out. Oh, perfect. Set to, yeah, higher tier. Yeah, that's fine. Because I added, do you see how they said they've mixed A and B to make C? So the mass of A plus the mass of B gives me the mass of C. They've added them together. They've just put both in the same like container or whatever. You did it the same way. Okay, perfect. Yeah, that's probably what I would do. Just list out the 3, whichever 2 you've got, then you go, oh, I can work out the other one. Yeah, okay, fine. Right, so we'll look at the hexagon question now, and then we can move on to your guys' requests. Okay, so the hexagon question. This was on last year's paper. You might have had this in your mocks. June 2024. Paper 3, this was a calculator. As you can see, question 21. I think this was literally the last question. It was 4 marks. It wasn't even 5 marks, but it was 4 marks. Okay, so I think the problem with this one is it's quite a vague, like the wording is quite vague. It's quite hard to figure out what to do. It's not maybe that the calculations are hard, it's just knowing what to do. And because it's, yeah, when I went through it myself, to be honest, I only got 2 out of 4 because I wasn't really sure the last bit. Like I could kind of figure out the perimeters, which is 2 marks. If you find out the perimeters of both, it's 2 marks. But then I just didn't make the link at the end, basically, which is kind of the easiest bit, actually. Once you've got the logic, it's really easy. This will be probably for another hour or so. But if you want to go through a past paper or a predicted paper, that will be at 7 o'clock, so you can always come to that, which will just be obviously questions from that paper, not just random questions. Yeah, exactly. That would be the first perimeter, the 6R. So, okay, so the diagram shows a circle with a radius R. So what I first did, before I even did anything else, was started drawing lines. As I said before, you can always draw any lines that you want to. You can always add lines in. So I kind of just split it straight through. That wasn't very straight, was it? But I basically split this up just to make triangles, because we obviously don't know really anything to do with hexagons in terms of formulas, but we do know triangles. So they've said that the radius is R, so obviously then do you see how like the side of each triangle, at least on the inside, that's R, you know what I mean, like all of those are R to the small triangle, right? Because the small triangle is the one here in terms of this corner that touches the circumference. So that's the first thing. Now, when I looked at the mark scheme, I actually worked it out differently because I was trying to work out the perimeter. So it says each side of the larger hexagon is a tangent to the circle, so that's obviously key information. Each side of the smaller triangle, smaller hexagon even, is a chord. So by considering perimeters show that you can get this. So basically what we're saying is we need to work out the 2 perimeters, right? That's kind of the first thing. Yeah, so you worked out the perimeter of the small one, so we'll start with that. That's kind of easiest. Now, what I was about to say is when I looked at the mark scheme, the way that I worked out the perimeter of the small hexagon was different to how they did it, which might be different to how you did it. The way that I actually did it was, now they did it by splitting it into right angled triangles and using like SOHCAHTOA, which you can do. The way that I did it was I just thought of, you know, the formula for the angles in a polygon is this, number of sides minus 2 times 180. And then if you want to find, because this is a regular hexagon, all of the angles are the same. So if you want to find one of those, you divide by the number of sides. So I just worked that out. I said, right, okay, for my hexagon, 6 minus 2, you don't have to do it this way, but this is how I did it, over 6. Now that gave me 720 over 6, which was 120. So like each of all of that is 120. Now, obviously, with my drawing, I've halved it, haven't I? I've cut all of those angles in half. So do you see how that would tell me that this is 60? Or like all of these inside the triangles is 60 and 60. Now, if both of those are 60, and I know it's isosceles and all of this, like this one obviously has to also be 60, doesn't it? Because it has to make 180. So what I realised about this was that it is an equilateral triangle. That's how I did it. I was like, oh, it's an equilateral triangle. Therefore, the perimeter of the small hexagon is 6 times R. That's how I did it. Now, as I said, you could do it differently. You could split it again. So, for example, you could have split this in half. Move that over a bit. You could have split them. Imagine that makes a 90-degree angle, right? Not drawn it very well. But that would be 90. And then you could go, well, you could work out like that angle. Or, for example, you could have, worked out that 60. This is 30. You could have worked that out. And then because I know the hypotenuses are, you could use, what's that, opposite hypotenuse? You could have used sin. Yeah. So in the mark scheme, they used trig. I just used it this. Obviously, they'll give you the same mark as long as you get the 6R. They don't mind. And it's mathematically correct. They won't mind if you've done it a different way. So either way, you could have used that. So that's the first mark, right? That's one mark. The second mark is for finding the perimeter of the big one. So this one, actually, it took me a while to kind of figure out, but we can draw more lines. Back to the fact that they said the radius of the circle is R. I'm going to come and use one of these other triangles over here, right? If I draw a line here, so it's touching my bigger hexagon, that's also, it doesn't look like, I know it kind of looks odd, but that is also a radius, isn't it? It's also a radius. So, and also then that's why they've told us they've got a tangent, because if you think about circle theorems, do you know how obviously the tangent and a radius is always 90 degrees. So I know 100% that is a 90-degree angle. And then if I just extend one of these lines, I don't know if you can see that, but that's also a right angle triangle. Maybe if I get a different color, you can see better. That's also a right angle triangle, of which it's still 30 degrees at the top, isn't it? And it would still be 60 degrees down here. So you can use either the 30 or the 60 degrees, whichever you prefer. Do you see how this creates a triangle? And because of the fact that we know the circle theorem, we know it's 90 degrees, we know that that side is R because it's a radius. It took me a while to see that. I was focusing too much on the smaller hexagon. But yeah, that you can either use this as 30 degrees and then do, again, SOHCAHTOA. You could use this angle as 60 again, because it's still a hexagon, isn't it? So it still becomes 60 over there. So in this case, if I use the 30, what have we got? I want to find out the opposite. Now, obviously, that's only half, isn't it? So just remember that, half of the side. I've got the adjacent, so that would be tan. TOA. And I'm looking for the opposite, so that would be tan 30. Obviously, it would probably be a different one if you use the 60 degrees, but that's fine, times R. Now, tan 30, what does that give me? Root 3 over 3R. Now, that's only half of a side, though. So if you're making it into the whole perimeter, you'd have to times that by 12, wouldn't you? Just remember that it is only half. That one, we'll call that one the big one. So it'd be like 12 times this. Oh, no, that's a 3. Which gives you 4 root 3R. So that's the perimeter of the big one. That's kind of how far I got it. Yeah, I know, that's the thing. Once you've seen it, you're like, oh yeah, okay, I can kind of see where they've come from. So that's mark number 2, right? Just for getting the perimeters. The bit that I kind of struggled with was then I was like, well, yeah, but where am I getting the pi from? Obviously, I know I've got a circle and circle sectors and things like that, which have pi in the formulas, but I was finding it really hard to figure it out. And actually, the link is not as obvious as you'd think. As in, it's not like like in my head, it's a more of a loose kind of link. It's not really like an algebraic link, because I was looking for some kind of formula that would link it. So they said by considering the perimeters, now I don't know if you can see the 6R and then the 4 root 3 obviously relate to these two numbers. I know they've simplified it, right? But it relates to those two numbers, doesn't it? So what they've basically done is said, I just need to set up any inequality for the perimeters. So think about the perimeter of the small one is obviously the smallest, and then the perimeter of the big one is obviously bigger. But then think about the circle. The perimeter of the circle, or obviously the circumference of the circle, that's the same thing, isn't it? Technically, just looking at it, and this is what threw me, because it was just by looking at it, technically, the circumference of the circle is technically bigger than the small hexagon, isn't it? But it's also then smaller than the big hexagon, which I was like, that's just such a loose link to make. Like, I was expecting it to be some kind of algebraic thing that we'd figure out, but no, it's literally just, well, yeah, but the circle is inside both of those. Like, it's inside the big one and outside the small one, so it's within, isn't it? So then I put, okay, well, what's the circumference of a circle? 2 pi r. that's how they created the inequality, literally. And I was like, oh, that's just doesn't feel mathematical in my head just by looking at it and going, oh yeah, but one's bigger and one's smaller. Like, I just thought there was gonna be something that linked it more officially, I guess. So that's mark number 3, and obviously from there, then if you've got this far, you can simplify it, can't you? So all of the r's would cancel because there's r's on all 3 parts, and then you can see you've just divided everything by 2, haven't you? And that's obviously then the final mark. I just thought that was really annoying, to be honest, that last bit, because I was looking for something more substantial, you know, some kind of more official link between it, but it was just the fact that you just need to look at it and go, well, logically, that one's bigger than the circle, and then the smaller hexagon is smaller than the circle. So I thought that was kind of annoying, actually, that last bit. Yeah. Yeah, I guess there's another way to do it, but I think they literally just went, well, yeah, but just looking at it. You can just set up the equation just by looking at it, which I thought was kind of annoying, to be honest. But yeah, obviously the way that I've done it, you might have, you know, figured out the perimeters in a different way using different sin, cos, or tan. That's fine, as long as you get the same answers. It doesn't matter if you've done it differently to me. But yeah, I think the key thing you said about you didn't think about using trig, I think the key thing about all of these questions that are, sometimes there's, you know, it's always at the end of the paper, isn't it? It's always some kind of like really odd shape, circles, circles in rectangles, or maybe this one hexagons, things like that. And it's at the end, you know, at the end of the paper. And I just feel like most of the time it's something to do with trig. I know initially there's no triangles there, but just think, well, I only know formulas, obviously for circles, but I know formulas for trig and things like that, don't I? I don't really know formulas for hexagons and such. So just think, well, I always just think, how can I split up a shape to make it into triangles? And the same goes for circles. You can create triangles within circles as well. So I would just say, in that case, knowing to use trig, I would just kind of put it in your head that maybe if there's a question at the end of the paper that looks kind of insane and you're like, this is such a wild card question, and it's obviously shapes, right? Maybe just see if you can draw some triangles in there. That's what I would recommend. Because most of the time it is some kind of trig, I feel like, even though the image, the shape is different every time. What is the easiest paper? Oh, I don't know. Yeah, I guess because paper 1, I mean, as long as you know all of your mathematical kind of like non-calculator methods, you'd be all right. Because they can't ask anything too complex, can they? Because otherwise you would need a calculator. So I don't know if I wouldn't say it's meant to be easier, but I think it just depends if you are someone who's more confident without a calculator, or if you're someone who's more confident with a calculator. I think that's a personal, yeah. I don't know. I mean, I've been going through paper 1s recently a lot. I haven't looked at paper 2s or paper 3s. Like, I haven't sat down and done it myself recently. So, but yeah, I would probably agree. I think paper 1 for me is probably a little bit easier as well. Yeah. Okay, so yeah, that was that one. That was a wildcard question. But yeah, if you get these wildcard shaped questions at the end, just think maybe I could use trig. Just have a look and see if that makes sense to use trig. And also possibly sine cosine rules as well, if it's not. Like, you could have technically used cosine rule if you wanted to work out the length of this side, because you know this angle, you know the two sides. So you could have used cosine rule as well. You could have used SOHCAHTOA, you could use cosine rule, you could have used the way that I did it, which was like the angles and polygons like this. You know, there was loads of different ways to do it. It depends what comes to you first, doesn't it? Yeah. Okay, right, so those are the 2 questions I had to answer at the start. Let me go back and have a look. The congruent triangle, someone asked about congruent triangles. We did go through that the other day, so if you have a look at one of the other lives, we did go through that. But the graph transformations, trigonometric graphs, we can have a look at. I have got videos on that as well. Algebraic proofs. I also have videos on algebraic proofs as well. You know, just in case we don't go through it in this in the lives, you can also have a look at my videos as well, and then you get obviously more examples. Yeah, vectors is one that's always asked about. So one of the first lives, I've actually labelled it. If you go through my lives playlist, one is called vectors, and I also have videos on vectors as well. So we have gone through vectors at some point, but you can have a look at that live if you want. This is Edexcel mostly. Yeah, Edexcel. Just checking, because obviously we've gone through. Then the person who wanted to go through graph transformations, are you still here? If not, then I'll move on to the next on the list. Combinations, I'm not sure what you mean by combinations. Do you mind like expanding on that? What you mean by combinations? Just having a look through the chat. Someone mentioned circle theorems. I think that was the next thing on the list. Yeah, circle theorems, yeah. Oh, combinations. Oh, right. Okay, yeah. Product rule for counting. That makes more sense now. Is that the one? Is product rule for counting? Is that what you're talking about? Where you just normally, so for example, sometimes they say there's this many starters, this many main courses, this many desserts, and you have to work out how many combinations. We can go through that. I also have a video on that as well, separate to this. Yeah. Oh, yeah. Okay. So your question was next. We'll do I just noticed product rule for counting, but yeah, I guess combinations also makes a lot of sense, considering that's the word they use in the actual question. Let me grab some questions. Yeah, normally you just multiply them together. Obviously, it depends on the context if it's a little bit harder than that, I guess. So I'm going to do the lock one, because I feel like this one kind of explains it quite well. Just got a part A and a part B, this. Okay, so there are 3 dials on a combination lock. Each dial can be set to one of the numbers, obviously 1, 2, 3, 4, 5. The 3-digit number 553 is one way the dials can be set, as you can see. So work out the number of different 3-digit numbers that can be set for the combination lock. This one's really straightforward. You just say, I always think of it as, because obviously the context changes, right? I always think of it as categories. So like that's category number 1, category number 2, category number 3. Now in terms of this question, they don't affect each other. So how many options do I have in my first dial, my first category? I have 5 options. And then you always times it, right? So times. Then I go to my second dial, my second category. How many options do I have? 5 again. And then my third one, how many options do I have? Another 5. So yeah, someone has said in the answer 125 would be part A. That's part A. Now part B. And let me click on it. Let me try and grab part B. There we go. Now I can click on it. There. Right, this was the part B. Oh, that's really blurry. Hopefully you can still read that. So how many of the possible 3-digit numbers have 3 different digits? So the first one was obviously, do you see how they repeated 5, 5, and then 3? That's repeating, right? So I had 5 options every time. This is obviously now more specific, so that's what I'm saying about my categories. When I choose my first dial, because I haven't chosen anything yet, I can choose any of the 5, can't I? So that's 5. However, when I then go to my second dial, if I've already chosen 1, as in it doesn't matter which number I chose, I've already chosen one of the 5 numbers. To get a different number for my second dial, there's only 4 options left, isn't there? Doesn't matter which ones they are, but there's only 4 left. So see how that would then be 4? So my first category, my first dial, does now actually affect my second one, and my second one obviously affects my third one. So when I look at my third dial, I've already picked 2 numbers previously, haven't I? So out of the 5, there's only 3 left. So in this case, that's the difference. So sometimes it's just multiplying them all together, and that's if the categories, or in this case the dials, but the categories, if they don't impact each other. So you know when you have like I said, a menu, a dessert, a main course, like a starter, normally those categories don't really affect each other, so you just multiply all them together. In this case, this is a scenario where they do impact each other. I can't repeat the same number. So I think that makes 60, does it? I think that makes 60. Yeah. Yeah, sometimes it's just the numbers multiplied together, which is why I'm kind of mentioning about whether the different categories affect each other. In part A, they didn't. I could repeat numbers as many times as I wanted. In part B, the categories in this case, in terms of the dials, they did impact each other, didn't they? They did affect each other, right? So I had to do 5 and then 4 and then 3. So that's kind of the thing with product rule for counting. You're always multiplying, but it's like, do they affect each other? Yeah, I don't know if you'd actually use this in the real world, to be fair. I don't know. A lot of it, not really, I guess. I guess it's more the percentages. That's the most helpful thing, probably, in the real world. So here, for example, it's just such an easy 2 marks most of the time. Raheem has 16 shirts, 5 pairs of jeans, 3 jackets. Do you see how shirts and then jeans and jackets don't really affect each other? The categories don't affect each other, do they? So obviously he's going to choose an outfit to wear, 1 shirt, 1 pair of jeans, 1 jacket. That's the most straightforward example. You would just multiply all of those together. This is obviously a calculator on this one because the numbers are bigger. But do you see what I mean? Like, this doesn't impact at all. Yeah, exactly. That's the one where you just straightforward just multiply. Yeah, I think the team one is that's when it starts getting a little bit more complicated, isn't it? 21 teams in each team. If 4 matches are cancelled. I don't know if I've seen that one. I've seen ones with teams on. Yeah, we can do completing the square after this, yeah. Yeah, the team question is... So that's like the most... As long as you kind of have got that basis knowledge, that's the base part of it, isn't it? Sometimes they also ask you to do it backwards. They'll say, for example, I've got 16 shirts, 5 pairs of jeans, and how many jackets, and then they will tell you the number of combinations. Obviously, you then just divide it. You just reverse it. That's also quite straightforward. Hang on. I have like a hockey team one. I don't think that's as complicated as the one you've mentioned, though. It's still only 2 marks, so that's the thing, even though it's, I guess not as straightforward as the one we've just done there. It's gonna let me paste it. Nope. P. There, paste. These are just from past papers, right? I don't think this is as complicated as yours, but maybe doing this one, it might help you figure out your one as well, I guess. So there are 16 hockey teams in a league. Each team played 2 matches against each other. Against each of the other teams, right? Work out the total number of matches played. I think that one's complicated because of the 2 matches thing. I guess that's the bit that maybe is more complicated. Yeah, now the thing is, obviously in this one, when you're thinking of team 1 playing team 2, you obviously can't play yourself, can you? That's the only thing. So if out of 16 teams, that like one of the teams can only play another of the 15 teams, can't they? They can't play themselves. So yeah, when you put 16 times 15, that's what you'd have to do for this one, because just think of the context. They can't, like, category 1, so the first team in the game affects category 2, doesn't it? You can't play yourself. So it wouldn't be 16 times 16. So it would be 240 for that one. Just think about, yeah, they can't play themselves. Now, I think what they mean by I think when they say 2 matches against each other is like for example, let's say you have team A and team B. They could play A against B, but they could also play B against A. I know that's, so that would be the 2 games, wouldn't it? So think about the one with the lock where we did the first question was you could repeat numbers, the second question was you couldn't. I guess that's the same logic, like you're repeating the numbers, although you're repeating the teams but in different orders, aren't you? So I didn't have to double anything because it was already accounted for. Yeah, they have on the mark scheme, they've got like 4 they got 4 different ways to do it on the mark scheme. So as long as you've got the 240 at the end, then I would assume that would be fine, because they have got loads of options on the mark scheme. That was just what I was thinking. Yeah, they've given different possibilities, so as long as you get the same answer, then I think it's fine. So in this one, you've got 16 hockey teams in a league. They're going to play against each other, like one team against the other team, isn't it? 16 times. Yeah, that's what I was trying to explain about the two matches, because I think that's the bit that throws you. And the other bit's fine. It's more when they mention the 2 matches. I think what they mean by that is, as I said, you could do team A against team B, and then B against A. That's the 2 matches for A and B, right? They're still the same 2 teams, but they're playing each other twice. If you think about the one where we did the lock, hang on, let me go back. Do you remember how part A was 5 times 5 times 5? That accounted for every different possibility, didn't it? That accounted for repeating numbers. So in our case, we're repeating A and B, B and A, we are repeating it. So that was already accounted for. Yeah, you're right, because if you did 16 times 15 times 14, that's like 3 people playing, like 3 teams in one match, which obviously, you know, when you play games, there's only ever 2 teams, isn't there, in a match? That would kind of be like if there were 3 teams. Yeah, and also in terms of the 15, the way the 15 came out from is because like team A cannot play themselves, can they? So once you pick team A, out of the rest of the teams, there's only 15 teams you could play left. Do you know what I mean? You can't play yourself twice. Well, you can't play yourself once. You can't play against yourself, and obviously not twice. So the 15 comes from the fact that you can't do yourself times yourself, but it encompasses the 2 matches. Like, you don't have to double it or anything, because that's just already included. Yeah, it's quite, I don't know, I feel like this one doesn't make as much sense as some of the others, the team ones. There's just one more example that I'll show you on a team one, and then we can look at something else. It was a part B. Part A was something else, which I think was kind of an easier question, but part B is the team's question. Again, you can see it's 2 marks. Most of them are 2 marks, so really I wouldn't kind of stress about it. So 12 teams play in a competition. Now in this case, you see how they've said each team plays each other team exactly once. So in this case, let's say they did A and B, they don't do B and A. Like the other one they did, didn't they? In this case, they just do like A against B. Okay, that's done. So for this one, you would do 12 times 11 in the first place, because obviously you've got 12 teams. Once you've picked one team, there's only 11 left to choose from, because obviously you can't play against yourself. So that would be 132. 132, though, that would include if I did do A against B and then B against A, so that would be 2 each. So then you would have to half that. In this case, you see, because they only play once, you'd have to half it. I think it's 66. Yeah, you'd have to half it, exactly. I mean, I'm showing you the harder ones. I mean, most of them are kind of easier than this. I think it's just the team ones that don't really make a lot of sense, maybe. But I've only got 2 examples of the team ones. The rest of them are, I think, okay. Most of them you just multiply. If in doubt, just multiply all the numbers together and hope for the best is what I would suggest. That's kind of my recommendation if you're not sure. Because sometimes it is just multiplying them together. So So yeah, that, I mean, those are the harder ones of product rule for counting or combinations, but some of them are much easier than this. We just haven't looked at them, I guess. Okay, just going through in the order. I think a couple of you said circle theorems. Still want to do circle theorems. Transforming graphs. Harder trig graphs, things like that. I'm just trying to go through an order of the questions. Yeah, because, so do you see how it's different to the previous one? They said they played 2 matches against each other, so that accounts for, let's say, picking Team A first against Team B, and then also the possibility that you could pick Team B first and then play against Team A. That's 2 games, isn't it? Of the same 2 teams. That's 2 games each, isn't it? Whereas here, because they said exactly once, do you see how I'm saying I can only do, let's say, A against B or B against A? I can't do both. So that's only 1 game. So we times it, but then we had to half this one. The previous one we didn't half it, did we? This one we did, because they only played once against each other, not... Do you know what I mean? It's like you can't have the reverse. You can't have A and B and then B and A. You can only have one of those options in this particular question. Yeah. Hopefully that answers your question about the dividing by 2. It's just because they only wanted it once, whereas the previous one wanted it twice. And we see how the previous one we didn't divide by 2. It already included 2 games each. This one we had to half it. Circles to improve. I feel like that very often. If I have questions on that. Let me see if I can find questions on that. Okay, perfect. As long as it makes sense, that's fine. A lot of these, ones that you're asking for, I don't have necessarily everything, but because obviously the syllabus is so huge, I've only just started. But some of these that you're asking for, I've done videos for a while. We've already got videos on the channel for, so you can also have a look at those as well. Yeah. Yeah, I was asking about, you wanted to go through trigonometric graphs, congruent. I mentioned earlier, we went through congruent triangles the other day, so I'm trying kind of not to repeat myself if the same people are turning up. So you can have a look back at, I can link it in the comments, the one where we went through congruent triangles. However, we haven't gone through trig graphs, transformation graphs. We can go through that, because I know your question was next. But as I said, I do have videos on that separate, like not lives, but I do have actual videos on the trig graph transformations and transforming graphs. I do have videos on that, so you can have a look at that as well if you want, but we can have a look at that. Let me just do that because that was the first question. Hang on, graph transformations. Graph transformations are fairly straightforward. You just have to memorize the graph transformations. I guess that's the hardest bit. As long as you memorized it, then you can pretty much apply it. Obviously the trig ones are a little bit harder, but it's more so if you've got them, got them memorized, then you'd be all right. So the first one you need to know, there's obviously 3 types of graph transformations, right? And then within those 3 types is obviously the version for x-axis, the version for y-axis. So you've got reflections. These are what you have to memorize, right? This is where it's just like a negative. There's no number, it's just a negative. And then you have to remember which is x and which is y. That's, I guess, the bit that's harder. So this one here is a reflection. Let me just write x-axis, in the x-axis. You'd think it'd be y-axis, it's not, it's the x-axis because it changes the y-coordinates. This one is a reflection in the y-axis, sorry, because it changes the x-coordinates. Does it normally come on paper 1? No, not that I remember. Not that it can't. It could do, obviously, but I think not, because I went through when I made my own predicted paper for paper 1, it wasn't one of the most common things to come up. I think one of the most common things to come up in, not this type of transformation, but you know the ones where it's like an actual triangle or something on a grid and then it says rotate it or enlarge it, like that type. Not this type. That type tends to come up on paper 1, I guess. But it could be any, I mean, you know, you just don't know. It doesn't have to necessarily be calculator or non-calculator. So reflections. Then you've got translation, which is where you move it left and right or up and down. Obviously then you would need numbers, wouldn't you? So that would be y equals x, obviously plus or minus, right? I'll put a, but that means the number, right? And then obviously then on the outside, it's either on the inside or the outside. That's kind of the difference. Now, there's always something, this is how I remembered it when I was in school. There's always something wrong about the x-axis. So this one is the x-axis. However, what you have to memorize is that the symbols are kind of the wrong way around. So if it says plus, you actually have to go left. And if it says minus, you actually have to go right. So that's like the wrong way around, isn't it? So kind of annoying, but just remember there's something always the wrong way around. Same with this is kind of the wrong way around to how you'd probably imagine it. The y-axis, though, is normally correct. So if it says plus, you go up. If it says minus, you go down. So that one's fairly straightforward. So those are the main two. There's then also enlargements, but I feel like enlargements are normally mostly just for the trig graphs, because you know how the trig graph, like so for sine or cos, they have vertical limits, don't they? So it's, I feel like enlargements is more so for those, but I guess it could come up. Again, enlargements will have a number, but it won't be plus or minus, it will be multiplied. So you have to kind of figure out that difference. So for example, hang on, no, not like that. It'd be like ax. You see how that's different to plus? A is like multiplied. So that one is the x-axis, but again, there's always something wrong about the x-axis. So you have to multiply by the reciprocal. The reciprocal. Or effectively divide by that, whichever way you want to remember it. And then obviously the y-axis is on the outside. Yeah, it would be here, wouldn't it? And let me write that again. A, and then do you see how it's multiplied? It's not, there's no plus or minus. That is the y-axis, and the y-axis, as I said, is normally completely straightforward, so you would just multiply all the y coordinates by a. The rotation, normally in your exams they should give you tracing paper. So what I would suggest is obviously just put your tracing paper on it, draw the shape, and then just test out like putting your pen on different coordinates until it rotates to the other shape, if that makes sense. That's probably the best way that I would recommend it. Obviously the rotation's normally, well, not necessarily, actually, let me not say that. But yeah, I would probably use the tracing paper just to test it out, and then that'll be the easiest way to find yeah, the point of rotation. That's probably what I would do. I don't know if there's a different way. Yeah, some people might just be able to look at it and just figure it out. But I think, yeah, I would probably just use your tracing paper, because I think that'd be that wouldn't take that long. If you draw it on the tracing paper, stick your pen on different locations. Obviously, make sure you've rotated it the correct amount that they've said until the point where the other one like overlaps with your tracing paper. That's probably what I would do. I think I don't know if there's a more official way to do it, but that's probably what I would recommend. So yeah, here are the 6. Obviously there's 3 of them, but then each of them has 2 each. So you do have to memorize all of these. But if you've got these memorized, then you just apply them. So that's the application is fairly straightforward if you've got all of these. Let me get a couple of questions. Graph transformations. As I said, the trig ones are a bit harder, so we'll do a couple first and then we can have a look at a trig one. So feel free to screenshot that, but I do have a video on it, so you can have a look at that video, and I've got them listed there in kind of a nicer, typed up, not with just my handwriting. So for example here, I mean, it's not normally that many marks, to be honest. You would have to look at this and go, well, from my memory, what is that? Oh, I thought they just gave you tracing paper from the start. I just assumed that they gave, like, everyone had tracing paper. I think that's when I did it. They just put it on your table. Maybe in that case, you could ask for it at the start of the exam and then just see if it comes up or not, I guess. Oh, you had to ask. That's annoying. Maybe just ask it. Yeah, maybe just ask from the start. So you're not waiting for it when you actually want the question. Yeah, I remember we were just given it, I don't know. But then, I mean, that was like centuries ago at this point, so who knows. When I draw a graph, I would use a pencil, because if I did it wrong, I wouldn't be able to rub it out otherwise. So I would use a pencil. It's quite high risk if you use pen and then it goes wrong. Yeah, I think I would use pencil. So yeah, you just have to look at this and go, I remember, do you know what I mean? I remember what this is. So in my head, I know, first of all, I kind of go through this process of elimination. Of the 3 types of transformations, what is it? It's a translation, because it's -2. It's like moving up and down, left or right. Then I go, well, which axis is it? Obviously, you might just be able to memorize it immediately, but which axis is it? In that case, it is on the x-axis. However, the x-axis is always something wrong. So actually, instead of going, like, you think you'd go left, wouldn't you, because you're minusing 2, but the x-axis has said always something wrong. I'm actually adding 2. Now there's only one transformation there, so it's only affecting one set of coordinates, so obviously the x coordinates. So in this case, because they said sketch, you don't have to do it exactly, just pick a couple of the coordinates that are exact. So like obviously the turning point, so also be careful of the scale. So that's 2, 1, 2. So here, maybe these 2 where they cross, 1, 2, so that'd be here and here, and then probably at the top. Like, I wouldn't use these ones that are in the middle, do you know what I mean? They're kind of in an awkward place. 1, 2, there, and then obviously join it up. So it's just a sketch. Like, oh, that was horrible. It doesn't have to be exact. Obviously you do a better job than me on a piece of paper. But it's just memorizing them. That's really all I can say. It's just memorizing these. That's the problem. Now, whether they then put 2 together, sometimes they might put 2 together. I guess that could be the harder one. I think this was actually in our paper that we went through yesterday, this question. I'm going to just copy across. So this one has 2 transformations, and then the thing, I guess the trig ones are the harder ones. There we go. So do you see how this one, do you see, because there's 2 numbers, there's obviously 2 things, isn't there? There's 2 transformations there. Now they are both a translation, but the one in the brackets is obviously the x-axis, so that's the opposite way, so that'd be 1 to the left, taking away 1. And then the other one is also translation, but it's going down by 3, isn't it? Yeah, 1 left, 3 down, exactly. Now, when you've got 2 transformations, if you want to, you can kind of draw an interim sketch. Like, what I mean by that is draw one of the transformations and then from there draw the second one. I would probably recommend that, because sometimes there's like a reflection and then a movement, so that's kind of hard. In this case, this is quite straightforward, because it's just, as you said, 1 to the left, 3 down. So this one you can probably figure out straight away. But if you do want to do kind of 1 to the left, draw that, and then 1 and then 3 down and draw that, obviously just rub out the one in the middle, right? You can do it in 2 steps. It doesn't matter which order you do it in either. So yeah, I would just, again, pick some solid coordinates. So 1 to the left, 3 down. 1 to the left, 3 down will be here. This one, 1 to the left, 1, 2, 3. Yeah, and then this one probably 1 to the left, 3 down. There, and then 1 to the left. Do you see what I mean? Like, I'm only picking kind of the easiest solid coordinates. Obviously you would use a ruler. Don't just draw it like I've done. But that would be that one. So sometimes they do apply, you see you've got 2 marks, sometimes they do apply 2 of them into 1. The only other thing to consider is see how they've mentioned the point, the coordinates of A? This was the part B. Sometimes they might get you to figure out after a transformation the new coordinates. So this is part B. Hang on, let me scroll down a bit. Yeah, hopefully that's not too tiny. Just trying to fit it all in. So the point A, -2, 1 lies on obviously the graph. Now just be careful, because that is the original graph, right? We're not talking about our answer to part A. We're looking at the original again. So when the original graph is transformed to the graph with equation y equals f of -x, so again you have to recognise what that is, point A is mapped onto point B, what would that be? So in this case, because there's no numbers, it obviously has to be a reflection, right? You can't move it left or right, up and down, or you can't scale it if there's no number. So it's obviously a reflection, but then where is the reflection? That's the bit you've got to remember. It's a reflection in the y-axis, because the x-coordinates are the ones that are changing. So imagine my mirror line is vertically here. Where would A go? Well, it was 2 to the left of the mirror line, so now it would be 2 to the right of the mirror line. That's where B would be, isn't it? So you might have to figure something out like that, for example. So that would be 2, 1. See how it was only one transformation, so only one of the coordinates changed, not both. The one, in terms of the y coordinate, that was still the same. It was the x coordinate that was affected. So you might have to be asked, you might have to figure out coordinates as well, but again, I think if you've memorized this, it's not that hard. I just want to get a trig one really quickly, because I think that's where they get a bit harder. You have to interpret it a little bit more. Where's it going? Oh yeah, this is a good one. So you can see they've obviously drawn the sine graph from -180 to 180. So they've then said, in the case of trig graph transformations, you see how all the other ones they used f of x? That was the format. In this case, they won't. They will use sin, cos, or tan. So you then, it's just like you have to interpret it a bit more. So I have to kind of figure out what this means. Now, one of the key things for trig graphs is that obviously vertically the y-axis is in terms of 1, 2, 3, 4, and then the x-axis is in terms of much bigger numbers, so like maybe 30 degrees, 45 degrees, 90, like bigger numbers. So you can almost interpret that as to which is the y-axis and which is the x because of that. In this case, you see also they put a little kind of, sometimes they might put brackets, sometimes they don't, sometimes they put the degree symbol. So if I were to translate this into f of x, I would write it f of x, and then the -2 is on the outside. Yeah, you just have to figure out, is that the -2 relating to the x-axis? Because it's not obvious, is it? Or is it relating to the y-axis? Well, mostly they're not going to make you move a graph only by 2 degrees, first of all. As I said, the x-axis translation, for example, would be like 30 degrees, maybe like 15, but like a bigger number, 20 degrees, 50 degrees, 90 degrees, it's not going to be as small as 2. 2 is obviously y-axis. And also, do you see that they've closed the x? Like it's kind of like, if I were to put brackets, I'd put it there, because they've put that little degree symbol to kind of close in the sine bit, and then separately it's then -2. So this one is moving down by 2. So I feel like the trig ones, it's obviously still the same transformations, but you just have to kind of interpret it a little bit more. So obviously then just pick some, solid coordinates, move it down by 2, so that'd be there. This one that was at -1 would go to -3, -2. That one that was at 1 would go to -1. Do you see what I mean? Like, I'm just picking some solid coordinates, and then I would try and draw it fairly nicely. So the trig one might be a little bit harder just because of that. So just be aware of that you have to try and interpret it a little bit more. And sometimes they have 2 in 1 as well. So just double check, is it just 1 transformation? Is it 2 transformations? But it all comes back to just memorizing the 6. That's all it kind of comes down to. So I don't know if that answers your question on transforming graphs, trig graphs. It's not, yeah, it is just down to memorizing it. Once you've memorized it, then maybe obviously give it. Oh, the one, not in this one, the one left was this one here. Because it had 1 left, 3 down. That was the other one. That was this one here, not the one that we're currently looking at. Yeah. The one that we currently looked at was just 2 down. The person who's asked for sequences, I also have a video on sequences as well. So again, have a look through my channel, see what videos are already there as well. Because that might answer some of your questions. Okay. Okay, hang on. The completing the square one. Completing the square. That one I have got also a video on. It's called Completing the Square Harder. So you can have a look at that. I'm just saying because we'll probably finish this live in like 10-15 minutes. Obviously, I can't get through necessarily all of the topics. So yeah, any of the ones that you have that I already have a look in my channel. 3D Pythagoras trig. Yeah, the plane question. I think we mentioned this before. The one where you had to figure out the angle between like one, not really a side, but like a line and then a plane. You just have to know which one that one is. Yeah, so George, I was saying that for your completing the square question, I have a video that goes through exactly that. It's called Completing the Square Harder. So you can always have a look at that. There's loads of examples on that one. It should answer your question. The 3D trig one, it would also be in one of my... It should be in my 3D trig video actually, because I think I would have made sure to go through that specific question. So you can have a look at that as well. Algebraic proof. Again, I have a video on that. I'm just thinking if there's anything that I don't have a video on that would make more sense to explain. Plans and elevations. Yeah, I don't think I have a video on plans and elevations because just yet, but also it doesn't come up a huge amount. Let's see. For plan and elevation, you just have to memorize what a plan means and what an elevation means, really. That's effectively kind of it. So the plan is like a bird's eye view. If you were to just look down on it, and the elevation, it could be the front elevation or the side elevation. Normally they will specify, but it's like if you were stood in front of it, just looking straight ahead. Imagine that as a 2D shape, and then if you're looking from the side, obviously same thing. That's the elevation. So the plan is just like the bird's eye view, and then the elevation is just looking in front of you. So I think I have a question here. They normally give you some kind of grid as well. Yeah. I think I got like three or four questions on this from the last 6, 7, 8 years. So obviously here you have a 3D trapezium prism. On the centimeter grid below, draw the front elevation and the side elevation. So in this case, that would just be, as you can see from the front, that's like a trapezium shape, isn't it? And then from the side, you would just be whatever you see looking from the side. So the front's a bit more straightforward. The side, I guess, is the bit you need to figure out. So we'd have to also, we'd also have to figure out the scale, right? Because they've given us a different scale. So obviously each of these like squares is 1 centimeter, but then they've put it to 2 meters. So 2 centimeters on your grid would be 1 meter, sorry, on the actual thing. So let's say the front one's fairly straightforward because you say, right, it's obviously just one face. It's just 2 meters across, half a meter up, and then 2 meters up that way. But obviously I need to convert that, right? So into my 2 centimeters is 1 meter. That would be like 4 across, wouldn't it? 4 centimeters or 4 squares across. That would be 4 up. And I guess that's, what, 1 up? So you just draw it wherever. Just obviously leave enough space for the other one. So 4 squares, 1, 2, 3, 4. 1, 2, 3, 4, and then 1 up, and then obviously join it. Oh, not like that. So that would be your front elevation. You just make it 2D effectively. What you can see from the front, you can only see that side. Now from the side, it's a bit more interesting because obviously you can see this small rectangle, but then there's this kind of diagonal plane as well that's technically in that direction. So that's the bit that I think is probably more confusing. They've given you 2 marks for each, so you would get 2 marks for that one already anyway. So obviously this one is, I mean, either way, the whole width of it is 2, like 1 meter is 2 centimeters across, isn't it? But the height of it is what we've got to figure out. Now, obviously, because you're making it 2D, you're not going to make it slanted. Like, we're going to kind of ignore the slant, and we're effectively just going to draw almost like the height of this bit. Because that's, if you're looking at it, just try and imagine you flatten it. It would be the height of that, wouldn't it? Which would include this front bit and also the diagonal, but as a flattened version, like you're not going to actually draw it diagonally. So that second one for the side elevation should be 2 across, but it then should be 4 up, as in 2 meters up. I don't think you have to draw the line to distinguish between the 2 sides. I think it would be fine. Either with or without, I don't think they would mind. You could draw the line. I guess, yeah, I probably would. Do you see how, if I draw a line there, that small rectangle is this where's my pen? Is this rectangle here. And then the other 3 bits is then the next bit above. I don't know if that makes sense. Like, you're just trying to flatten the side view. And I'm not using the diagonal side length, right? I'm using literally just like a literal vertical height, which is the 2 meters, which is 4 centimeters. That would be the side and that would be the front. I don't know if that answers your question. If you were asked for the plan, they've not asked for the plan here, but if they did ask for the plan, it's like the bird's eye view. But again, I know this is diagonal, so just think of it as a flattened shape. The plan, my highlighter, the plan would be like this, technically that shape, wouldn't it, on the base? It wouldn't be the diagonal. So if I were to draw a plan, I would draw like 4 across, obviously to convert it into the scale, and then 2. The width would be 2 squares to make up for that 1 meter. That would be the plan, if they'd asked for the plan. So it's just remembering the plan is like vertically, like the bird's eye view. And then the elevation, it depends. It's either the front or the side. It could be either, but it's just like if you were stood in front of it, what would you see flattened? I think that's kind of all you really need to know about that topic, I think. And obviously just apply it to different shapes, basically. They might give you these and tell you to construct the original 3D shape. I've seen that with a cylinder, but it was kind of obvious because it had a circle, obviously, as the plan. So you could see that it was going to be a cylinder. So yeah, there's that. Okay, we have time for 1 more question. Does anyone have one last question? Anything that's not on my videos already? And then we'll finish, and then you can have a break, and then I'll be going through my predicted past paper at 12. I've got videos on circle theorems. I've got 2 videos. One video is just going through them, you know, the 8 different ones, which ones they are and all that, which you have to memorize. Then the second video is I tried to make up my own questions on it. So you could have a look at that if you wanted. I mean, I think circle theorems, obviously, as long as you've memorized it, right, that's the first step. Once you've memorized what they are, then beyond that, it's just practicing as many questions as you can find, because they're all kind of a little bit different, aren't they? That's the difficulty with circle theorems. So if you can try and go through as many questions as you can on circle theorems, that's probably my best advice. It's just picking up maybe some experience and seeing, you know, obviously some of the circle theorems maybe are more common than others. So picking up on which ones those ones are, and, you know, that's kind of my advice for circle theorems. It's a bit random otherwise, isn't it? A bit hit or miss. I have a link for the predicted paper. Yeah, it's linked in. So if you look at the live that will be at 7, you can see it already on my profile. It should be listed. You can see scheduled for 7 o'clock or whatever. If you click on that option, like that live, in the description I've linked a Google Drive link, and in there, hopefully I think you can access it. I think I've put the access right. In there, there's 2 documents. One which is the paper, just a PDF document, and then the other one which is another PDF, but that's where I've basically written my own answers and scanned it, so hopefully you can read that. Hopefully it's clear enough. But yeah, there's a link for it in that live. You could probably paste it here if you wanted. See if I can grab it. Hang on. So echoing through the speaker. I got my voice echoing through the speaker there. Hang on a minute, let me just grab the link for that paper. And I'll paste it in here, but it's also on there anyway. Just trying to put it in the chat. I think that's the link. Try that. Hopefully it will let you access it. If it doesn't, then I'll try and sort it out. But that should be the link. Vectors proofs I have videos for, and we also went through vectors in one of my first lives. So if you look through my lives like playlist, one of them at the very beginning is labeled vectors. So you can also have a look at that. Similar shapes. I don't think we've done similar shapes. Yeah, we could do some similar shapes, and then we'll take a break before the predicted paper. So let me just grab a question on similar shapes. This is obviously a oh, I've got it twice. This is obviously a bit more of a straightforward example, but just to get the basis kind of understanding of it. So they normally, I guess a lot of the time it's triangles. Sometimes they write them separately, sometimes they're overlapping like this. So they've obviously given you that EA is parallel to DB. They've labelled these, so I'm probably going to label that myself. So EC, the whole of that is 8.1. DC, so this smaller part is 5.4. And then what was it, DB? Oh, this one, 2.6. Now they have to give you what I'd call like a matching pair, like a pair of values that are, do you see how EC and DC are the same line, but obviously one is smaller, one is bigger. They have to give you a pair of values for the same 2 lines for each triangle, because you need to be able to find out the scale factor. You have to make a comparison of the size, don't you? So it doesn't matter which way round you figure out the scale factor. What would I normally do? I think I normally divide the bigger by the smaller, but it doesn't matter. You can do whichever. So first of all, you always have to find the scale factor of the 2 triangles. So obviously being similar, they're the same like all the angles are the same in that case, but one's obviously a bigger scale than the other. That's what they mean. So I would probably do 8.1 over 5.4. I'm assuming this is calculator. Check. Yeah, this was a calculator one. So I would just type that into the calculator. As I said, you can divide it the other way around if you want to. It then just depends what you do at the end. So for this, I got 1.5 or 3 over 2, whatever you want to call it, 1.5. So the big triangle is 1.5 times bigger than the small one, right? Now, then you just check what they actually asked. They asked me to work out AE, which is obviously then which side does that other match in the other triangle, obviously DB. Now, because I did it this way round, I know that I would just have to multiply because I have the smaller side and I want to make it bigger. So obviously multiplying by 1.5 would make it bigger. You just have to figure that out. If you divided it the other way round, so let's say you worked out the scale factor by dividing it this way round, also fine. I guess you should get 2 over 3, which is, I wouldn't write it as a decimal. It's like 6, 6, 6, 6 recurring, isn't it? In order to make 2.6 bigger, you'd have to divide by that. So it just depends. Whichever way around you do your scale factor, just figure out, do I then need to times or divide to get a bigger answer or get a smaller answer? I had to times it in this case. So that gives me 3.9. Obviously just make sure it makes sense that your answer, if it needs to be bigger, then it gets bigger, right? So that's like the basis of it, is just comparing. Now a harder question. Let me see. This is question 10, it's 4 marks. I'm assuming that would therefore make it harder. Copy it across. I don't know why this is letting me. Oh, there we go. Now I can get it. There we go. This one's 4 marks and it's question 10, so I guess that's a, like a harder version. The other one was not that many marks. So let's see, we've got the diagram shows 2 right angle triangles, ACB and DEB. So again, you can see they're overlapping each other. So AD, so that smaller section, so not the whole thing, but that small section there is 9. D to E is 2. D to B, 6. Okay. Calculate the length of CB. Where's that? Oh, the whole of the base. Okay, so in this one, we can compare. This was on a paper 3 calculator. Yeah, this one was. I have loads of videos on surds, by the way, because I'm going to finish this live after this question. But if you want to have a look through my YouTube channel, there's like 5 videos on surds. So you can have a look at those and it'll break it down for you. So in this case, we obviously need to look at creating our scale factor still, but the problem with this one, I guess this is why it's a little bit harder, is that they've given us DB, but not the whole of AB. So I can't, don't compare the 9 and the 6, right? Because A to D is only part of that whole side of the triangle, isn't it? So you would need to compare AB, which is obviously those 2 added. So I think that's like an extra layer of complication, I guess. So the 6 and the 15. So again, I tend to just do the bigger divided by the smaller. You can divide it whichever way around you want. So I would divide by like that, which I think gives us something 0.5. Yeah, 2.5, 5 over 2, 2.5. So what we're saying is the bigger triangle is 2.5 times the size of the smaller triangle. Now back to what they wanted. They wanted us to work out the length of CB. The problem being with this then again is that I don't have either, I don't have another one of that side, do I? Do you see how in the previous one we just took, for example, EB and times it by 2.5? I don't have that. So that's, I guess, also why this is a little bit harder. Now they have given me the 2 centimeters, so you're going to have to use the information that they give you. What I'd probably do is I'd probably use this 2 centimeters to work out AC, and then I would have 2 sides, and then I'd probably use trig. Or you could use trig, I guess, now to find EB and then times it by 2.5. I think I would probably use I think I'd probably find out AC. That's probably what I would do. But I think this one, there's a few different ways you could do it. Yeah. So I would do, obviously I'm making it bigger. So the 2 centimeters times by 2.5 gives me 5 centimeters. So that would be 5. And now, that was 15, wasn't it? If I look at the whole of the triangle ABC, or do they call it? They call it ACB, that big one. I know 15 and I know 5, so I could just use well, you could, yeah, I guess you could work out an angle and then use that, but I think a more direct way would be to use Pythagoras. So like label your sides. Obviously the hypotenuse is always C. This one can be A, this can be B. Those don't really matter as long as you get the hypotenuse as C. So then A squared, which is 5, plus B squared we don't know, plus C squared, and then you would just solve that. So this one I guess is harder, just, it's not even the fact that the similar shapes bit is harder, it's more so just this extra bit here. So B squared would be 15 squared minus 5 squared. Obviously I'll put that in the calculator. 200, and then if I root that, 2 decimal places, because I'm going to round it obviously now that I'm at the end. 14.14. Yeah, exactly, 14.14. That's the way that I would do it. They've obviously given loads of options they've given like 3 different options in the mark scheme, so you could, if you wanted, I've obviously used Pythagoras. As you said, you could use SOHCAHTOA, you could use sin in order to work out the angle and go from there. You could do that, as long as you get to the answer 14.4 at the end, then that's fine. Yeah, Pythagoras or trig, you can use either. I think in my head Pythagoras made more sense. It might make sense to you to use trig, that's fine. But as long as you get to the same answer at the end. So DBE you said is 19. Yeah. So that one, let's say if we did it that way, 19.47 dot dot dot. Oh. Dot dot dot. And then from there you wouldn't even have to work out any other angles. Like from there I would literally just go, well, I know the 15 for example, and then I can just find out the side from there. So for year 10s, I think it's kind of all the same, just doing past papers. Obviously, I don't know how it works in your school with your end of year exam, only include the topics you've done, because obviously being in year 10, there's going to be topics that you won't have done yet. So if that's the case, if they're only going to include topics that you've done in school, then do past papers, but maybe just ignore the questions that you know that you haven't done yet. That's yeah. I mean, you could save them to year 11. Yeah, obviously the topics on the channel are also GCSE, and GCSE starts kind of year 9, year 10 anyway. So have a look through the content on my YouTube channel and see which topics you have done. Have a look at the content on that. If you want to, like if you want to do past papers this year that aren't the same as next year, whatever your exam board is, you could save those ones for next year. If you wanted to, well, you've got 2 options. You can either, let's say you are Edexcel, I don't know what you are, but let's say you're Edexcel. What you can do is maybe do the AQA past papers for this year. I know it's like not the same wording, but it is the same topic, isn't it? So you could do that if you wanted, and then next year do your own Edexcel papers. Or I'm pretty sure you can access really, really old Edexcel past papers. You could do that. You know, like stuff from like 10 years ago. You could have a look at those papers and then save the more recent papers for next year. You could have a look. Yeah, First Class Maths is really good website. Yeah, Maths Genie, you could do all the questions on Maths Genie. I also, yeah, as you've mentioned, First Class Maths I think is really nice. Those questions are really good. They also have videos to explain the answers, which is helpful. So if you want practice questions, it's that. And you can go through, again, the specific topics that you know that you've done. Yeah, Maths Genie or First Class Maths is probably quite a good place to get questions for. Especially because I know First Class Maths, you can choose specifically Edexcel or AQA or whatever you're doing, so that might be more accurate, yeah. But yeah, have a look through the videos on this account if there's anything you maybe don't understand, and you can get an understanding from that. And yeah, I think maths is just practicing questions. Once you've got the understanding, just practice as many questions as you can, is what I'd recommend. Works for year 10 and year 11, it's kind of all the same, isn't it? So yeah. Alright guys, perfect. Well, I'm going to leave it there so we can have a break before the next live. The live will start at around 7, and that will be my predicted paper for paper 1, non-calculator. So if you want to have a look at that, feel free to come. If you want to just do the paper yourself, as I said, it's linked in the description there. Hopefully you can access it. And I will upload the edited video of going through that paper on Monday. It'll probably be like an hour long, I guess. It'll be a bit shorter than the live. So you can also watch it on Monday if you want. Otherwise, yeah, thanks for coming, guys. And I'm just going to end the live here.